Hello, so we're going to do a couple of videos today. This is one of two videos on double angle identities. What we're going to do in this video is we're going to establish the double identities for sine and cosine, and then in the next video we're going to look at an example of how we use double identity angles to help us simplify trigonometric functions. So let's get started. We know when we've looked at sum and difference angles, and we've looked at all the identities that come with sum and difference angles. And that's where the idea of double identity angles come from. So if we had, for instance, sine A plus A, we can rewrite this here as sine A cos A plus cos A sine A by the expansion of the sum and difference angles in terms of the sine function. If we simplify this a little bit further, we notice that we've got two lots of sine cos A, and in this format, so we end up with getting 2 sine A cos A, and then we can rewrite this over here. This can be rewritten as sine 2A. So this here is our first double identity angle that we've worked out, which is sine 2A is the same as 2 sine A cos A. We can do the same thing when it comes to cosine. If we look at cosine, if we had cosine A plus A, this here can be written as cosine A minus sine A sine A, according to the expansion of the cosine rule. We can then simplify this a little bit further and say, well, we've got cosine squared A minus sine squared A. So this here is another way that we can write the double identity angle of cos 2A. However, when it comes to the double identity angle for cos 2A, we'd like to have ways where we can simplify it so we got in terms of just sine or just in cos. In this part here, we don't have it in terms of sine or cos. So we want to be able to rewrite this so we can get that variability. And one way we can do that is by using a formula or an identity that you already know, which is sine squared A plus cos squared A. And if we want to rearrange this so we've got this in terms of the subject in terms of sine or cosine, we can rewrite this here as, let's make sine A, or sine squared A, the subject, which is 1 minus cos squared A. And we can do the same thing for the opposite side. Cos squared A is equal to 1 minus sine squared A. And what I've established here is a method I can use over here to find the two other double identity angles in terms of if it's in cos or we want to have it in sine. So for instance, let's have a look at cos here. If we rewrote this function over here and wrote cos squared 2A minus sine squared 2A, I want this in terms of cos only. And what I have over here is I know I have something that tells me that if I want cos, I take sine squared A, that's going to be the same as 1 minus cos squared A. So what I can do here is I can say cos squared A minus, brackets, 1 minus cos squared A. I've now got everything in terms of cos. And when I look at this function here, I can now expand it out and have cos squared A minus 1 plus cos squared A. And now collecting any terms, I will have cos, or 2 lots of cos squared A minus 1. And this here is also a double identity angle where I have cos 2A, but I need the answer just in terms of cos. And we can do the same thing over here when it comes to sine. So if I had sine squared A, or let's do this again, cos squared A minus sine squared A, but I now want only in terms of sine. Again, I come over here and I can say, well, I've got that. I can replace cos squared A with 1 minus sine squared A. So 1 minus sine squared A minus sine squared A. So therefore my final answer here would be, another way to write cos squared A would be 1 minus 2 lots of sine squared A. So this all comes about because of our original function using sum and difference angles to get our first double angle for cos. So we have one where we could simplify, so cos squared A minus sine squared A is a double identity angle, okay? We also get another form of cos squared A as a double identity angle as 2 cos squared A minus 1, or 2 cos 2A could also be 1 minus 2 sine squared A. So that's how we come about to get our values in terms of double identity angles for sine and cosine. Next video, we'll go over an example of how we can use these so you can see what the importance of double identity angles are.